Hey everyone, welcome to this webinar about AI hallucinations and why you should care if you're a developer. And first of all, let's just do some brief introductions. My name is Vishnu Vettrivel. I'm the founder and CTO of Wisecube AI. And I have here with me Alex Thomas. Alex, you want to briefly introduce yourself?
Yeah, I'm Alex Thomas. I'm the principal data scientist here at Wisecube. And yeah, look forward to talking to you all about Pythia.
Right. All right, so just briefly about Wisecube. Yeah, we were founded in 2016. We're based out of Seattle, a bunch of AI and data guys. We've been doing this for a long time. We focus mostly on the regulated industries like pharma and healthcare, and we work with a lot of different partners, big and small. Our focus is mostly on semantic AI, and I'll talk about it briefly in a minute. But so that's about us. And then let's move on to the topic at hand here, which is generative AI. So obviously, if you haven't been living under a rock, you know this is taken over the world by storm. As it's everywhere. There's all kinds of large language models and small language models, and all kinds of generative AI is happening here. So it's really permeated our ecosystem in a big way in the last year or so, and it's obviously here to stay. And the market is huge in terms of how huge it is. So some people think it could be up to like trillions of dollars, in 10 years or so. If you look at segments like life sciences and education, it's predicted to grow like 40 or 50% annually, and yeah, and billions of new products and software revenue that's going to potentially come out of this. And so yeah, so it's huge, it's growing, it's here to stay. But all the more important, like this whole thing we're here to talk about is reliability. Like, and it's as this technology starts to grow, we also are starting to see some of the downsides, right? Fact being able to be factually accurate and reliable in mission critical settings is always been important, but all the more trickier with technologies like generative AI. And the incidence of hallucinations are pretty alarming. Some cases, LLMs have hallucination rates up to 27%. And the cost of misinformation obviously can be very damaging. Obviously these public incidents we see where Google and Microsoft, and these companies have incidents where they rely on a chatbot that sort of makes up policies about refunds or other kinds of embarrassing incidents. But more importantly, it could also be really damaging in domains like healthcare. Like a misdiagnosis could be really life threatening, but also it could cost healthcare providers hundreds of thousands of dollars per incident. And the same thing in the legal field, where litigation costs can rack up those fees really high. And the financial sector also, poor investment decisions could lead to millions of dollars in losses. Downtimes could cause more losses, and of course, there's the whole concept of brand damage, right? So your brand is damaged. That could mean negative attention to your stock prices. That could have a huge impact on your overall equity portfolio. So clearly, this is a huge problem, and this is a real problem. There's real dollars behind it, and also potentially lives at risk, right? And so, what you know, and as you can imagine, this is something that the governments also have started to sort of catch on to, although at a slower pace. But you already see the EU's enacted its AI Act. It's happening. They've passed it. So what it means, companies are still trying to figure out how to sort of implement this and how to react to this. So that's happening. The U.S. has also issued an executive order on safe and secure, trustworthy AI. So that's also coming. So if it's not the financial and the reputational damage that we talked about earlier, the regulations are just another aspect of this that is going to be coming really soon, right? So either way you look at it, there's it's been sort of the Wild West so far when it comes to generative AI. I think that time is coming to an end, probably pretty quickly. And so as developers, we need to be cognizant of this and start thinking about, okay, how do we think about reliability into the solutions, the AI products that we're actually building, right? So, and so that's sort of where what we're here to talk about today is then, okay, so what would be a good reliability solution? Like, what were the sort of things that are challenges right now with this in this space, right? And so we sort of identify like three main areas where we think, you know, current solutions seem to be like having trouble with, which is like the scalability is the first one, where most of the solutions today like rely on having high quality training data. Where you're like, hey, I'm going to give this, a lot of high quality annotated data, and then I'm going to measure the LLM or my AI solution. I'm going to make sure it's good enough, and then and I'm going to ship it, right? Which is fine, but it doesn't really scale, right? So one, it's two reasons. One, it's only done at almost like to development time, and that's not good enough. It's like saying, hey, I'm gonna just run my unit test and I'm gonna ship my product, right? That doesn't really work, right? And so that's one of the limitations of most people we talk to, developers talk to, are like, yeah, I ran my tests and all the results look good, and like hallucination rates were down and like are pretty low, so we're gonna ship it. And I'm like, so, but how do you measure it in production? And they don't have an answer for it. So, um, and of course, the other problem we see is like a lack of explainability, because oftentimes what they would do is uh, they would just ask, use another black box model or an LLM to actually try to flag things as hallucination. And so it's not very clear as to why some of these things were flagged. And so that also can cause problems. And of course, the final one is the accuracy, where like if you are in a mission critical application like life sciences, then you need to have a high level accuracy and provable, accuracy that's benchmarked. And that's something that is probably table stakes for some of these mission critical domains. All right, so that said, we're going to talk about, okay, what more detail, what would be the 10 things that you should look for in a reliability solution that you're maybe considering, right? And at that point, I'm going to hand it off to my colleague Alex, who's going to walk us through those 10 things, and then we'll see you back in a bit. Alex, take it away.
Okay. So let's see, can I control the slides? Okay. Oh, next slide, please. So the first thing we want to look at is we want to look at the different kinds of use cases. And here we have them sort of categorized by the nature of the information that is going into the creation of the output of the response. So we have zero context one, and that's where the user is not necessarily providing any evidence; they're just asking a question. So this would be an example of someone just like directly asking a question of an LLM, or it could be someone asking it to, without again any context, just generate some particular text. Then we have the noisy context one, and that's where you're retrieving additional information to respond to the user input, but you're not entirely sure that all the information it's gathering is correct. So the perfect example of this is RAG. So the user gives a question, then that is used to search an index, and those documents returned from the index are used to generate the response. And then, of course, there's the ones where there's a very specific context. A summarization is a good example of that. That's where the user is providing the context, as opposed to either having no context or some other like data retrieval system given the context. So let's see. Yeah. So we have these three types of context, and you want to make sure that where your tasks lie, and to know what use cases you need to support. Next slide, please. So once we have the responses and the contextual data, the contextual data is going to be references, and that's usually either something that the user provided or something returned from like RAG, where you could refer to the facts coming from. And then there's other external sources that are maybe more structured type data, like a knowledge graph. And so we want to be able to extract the claims as necessary. Obviously, with structured data like a knowledge graph, You don't need to extract claims from it. It just has all the data in it. But for any of the text-based ones, you'll need to do that extraction. So here, our claims are formatted in the style of a triple. So that's a subject, a predicate, and an object. And by extracting the information in this format, you remove a lot of sort of the black box ambiguity of a lot of NLP models around it. So in this case, we have a text here where it's a 58-year-old man, history of hypertension, atrial fibrillation on Coumadin, and NIDM, or type 2 diabetes. And here we give some examples of the triples that are extracted. So, for example, the first triple is directly stated in the text. So, it has a history of type 2 diabetes. So that's the history of blah 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 and NIDM. And then the Coumadin treats atrial fibrillation. That's an inference from what's in there. So AFib on Coumadin. So it's not directly treating. Stating like a claim about Coumadin, but it's inferred from what that is because what's in the sentence. So once we've extracted these claims, there's a lot more we can do, because what we've done is we've extracted the information from the response and the references, and that lets us be comparing it in an easily quantifiable way. Next slide, please. So let's talk about these different kinds of triples and how they relate to each other based on what they're present in. So again, we have our claims extracted from references, ones extracted from the response, and those extracted from an external source of information, knowledge base, knowledge graph. So we have 4 categories. So we have those that are entailed by the references. So that is where we've extracted from the response and we can find support for it in the references. So we call those the entailment class. Contradiction is where we extract it from the response, but we find it refuted in the references. Then we have the missing category, and those are ones that are in the references but not present in the response. That's not necessarily bad depending on your task. Like, for example, summarization, you necessarily are going to have some missing because you're trying to compress the information. So you're going to have to lose out on some. And then neutral is where it's in the response, but we can't find it supported or refuted in the references. Now, the contradiction and neutral is where your hallucinations will be. Now, the thing is that not all of neutral will be hallucinations, though. Because of the vast training sets used in building these LLMs, they can generate statements that may have facts that are actually correct. They're just not in the particular reference or external sources that are in that particular use at that time. So maybe someone's done like some sort of RAG Q&A, and the LLM will produce some sort of statement that has a claim, but it's not found in any of the references, and it's not found in any sort of knowledge graph you have there as well. So we need to categorize these because this lets us move on to our metrics. Next slide, please. So this is our first metric we're going to talk about. This is how we talk about the factual accuracy of how LLM is doing. So in this case, we're going to take the entailment, which is the entailment rate here, 1 minus the contradiction rate, and a reliability rate. So, and we're going to do a weighted harmonic mean. So the reliability is something where there's a lot of flexibility. If you just have reference text and you don't have anything that can really check the neutrals, then we normally will discard the reliability part of it. But if you do, you can use like a knowledge graph to fill in some of the neutrals and say whether they're supported or not. And if you have a way of predicting whether a link should be there, like a link prediction model in the knowledge graph, you can actually even take the things that are not present anywhere and say, well, what's the probability of this claim being present on our graph? And then you can have that additional weight in there. So we produce this weighted harmonic mean. So that's going to be our factual accuracy. Next slide, please. So we want to be able to accommodate task-specific metrics as well, because if you consider like the previous one, we're not taking into account anything like oh well, what happens if it's stating a fact that we don't really care about that it's correct. It's a fact, but it's sort of vacuous. And what if we're really looking for like particular facts? We want those to be more powerful. So you can actually set up ways of weighting these facts based off of attributes about them. So maybe you're saying anything having to do with a drug, I want that to have this weight, and anything else have a lower weight. Or maybe you're saying anything that has a relationship regarding a diagnosis, I want that to have a very high weight. And so we can use these attributes of the claim, sort of like the entities that are in it, the predicate that's in it, and we can establish weights for these claims. So here's an example of calculating the entailment rate, but with the weights for the given claims. Another thing that can be done is that depending on the checker, so we have these different validators that can be used to determine what class a claim is in. So there's an LLM-based one, which uses an LLM to do the classification. We have a natural language inference-based one, and we have knowledge graph-based one. We actually have multiple of these, but like there's sort of like some easy classifications of them. And if you're using an NLI-based checker, you can then say, you could then provide a question context to say, I want my summaries to be able to answer these particular questions. And then you can go through with your NLI-based checker, and you can have a partnered Q&A evaluator model that will go to see if these claims answer the questions. You can do a similar thing with the LLM-backed ones, and you can give it the question in a specially made prompt. And knowledge graph ones, similar as I mentioned before, you can use like a link prediction model to weight things, and you can also like specifically weight the different predicates that you might find. So depending on your type of checker, you can do a lot of augmentation to get these like very task-specific metrics. Next slide, please. So an important part is a bit of self-reflection here. How do we know if a checker is accurately labeling these things? How do we know that we're correctly finding this factual accuracy? So we come up with this test. This is based off of so we take the notion of this summarization task. And what we do is we take a piece of text, and we treat it both as the reference text and as the response text. Now, in an ideal situation, it should come back with 100% entailment, 0% contradiction, 0% neutral. It potentially may have a non-0% neutral if like the LLM has added information, right? You'd think that, but we're not using an LLM in this case. This is just two of the same document. So it should be 100% entailment, no contradiction, no neutral, and the accuracy metric should be 1. And what we do is we have this similar calculation to accuracy, but instead we're doing 1 minus the entailment rate and the contradiction, and we do a harmonic mean of them. And so obviously the more contradictions there are, the worse this systemic checker error will be. And so far we've had pretty good results with most of our checkers. They perform pretty well. Let's see, next slide. Yes. So as I mentioned, there's these different checker validators, like where we're checking for the factual accuracy. But when you want to understand your system, there's actually a large variety of things you might want to check. And there will be things that will be like factual accuracy with those checkers. There will be things where you will have different models for it. Like we have a list here of some examples of it. So, for example, toxic language, that's an important one. You don't want your model to potentially be producing something that will hurt your brand, or perhaps even like say something that will perhaps harm someone. So what you can do is you can decide which of these validators run on your system. There are some that are configured to always run, but you can always add more. And we're growing our list of validators all the time. So you can have these all these validators run, and you can get the report out from them. So once you have all these metrics, There are reports that we can generate from them. So here's one where we're talking about the accuracy, like with the accuracy metric on the left and the metric breakdown on the right, so that you can get these updates. So like as your system is running, you can configure updates. So yeah, I think that's it for the slides. Just about the updates. Yeah. So as I said, you want to get these reports. So you want to do this continuous monitoring, and you want to do alerting for when it's particularly bad. Now, we're just at this point with this, we're talking about like, oh, just being aware when there's a problem. But you can also look towards with feedback for something like this, and consider potential interventions that can be done. So perhaps you have an alert that comes if language is determined to be too toxic, and you can have like a standard response that says, "Oh, we're having a problem generating a response for this right now." So instead of returning a toxic message, you can intercept it and say, "Oh, don't return that." So yes, and so having this system, you want to be able to integrate easily into whatever you're using for performing your LLM-based tasks. So here we have an example of an AI client application. It feeds it in. We process these things as they go. We process them live. We generate the reports. You get the feedback. You get the alerts, and then you can take those things and you can plug them into other parts of your system. But I think more importantly is that you can gather this information and you see how your model is working over time. And so as you see these values come out, you can also take the results from what we generate with a system like this, and you can use that to fine tune your model, and you can use that to generate examples for few shot tasks. So this is very valuable information. And if you're just doing sort of this like spot checking at development time, you're losing all this information. Yeah, I think that's it for this slide. There we go. So.
Yeah, and yeah, so thanks a lot, Alex. And so hopefully that just gave you guys an idea of the kinds of things that you should be looking for in an ideal sort of reliability solution. And by the way, there's one more thing is it just so happens that we have built a solution for this. It's at Wisecube, we call it Pythia, named after this priestess of the Temple of Apollo. If you're into Greek mythology, she used to deliver prophecies to, and it's supposedly by inhaling hallucinogenic gases. And so, you see the link there. So, but we have taken into consideration all of these things we talked about when we built Pythia. It's obviously, it can enhance reliability, reduce the risk of errors, but more importantly, can act as a way to sort of continuously monitor and react to the reliability of your system across different levels of metrics that you can configure it for, right? And hopefully, in a way that doesn't have to involve changing your current workflow or current application that you've already built, right? And it so happens we're running a little, closed beta of Pythia right now, and so we'd love to get feedback from people who are interested in trying it out. Yeah, and here's mentioned the link. We'll drop a link on the chat as well. But feel free to go here and sign up for the beta, or if you have questions, obviously we can take them live here now, or you can drop us a line at the emails mentioned here. With that, I think we'll open it up for questions.
Okay, sorry. So one way of doing this is with that systemic checker error metric we're talking about, where we want to make sure that it performs well under these sort of testing tasks. But there's also a lot of benchmarks out there around these different types of validators, where we can run against those. but also like we can incorporate a lot of these open source available models into validators. So yeah, I would say basically just trying to measure ourselves on benchmarks and on some of these like test-based cases.
Yeah, and on that note, just to add to what Alex is saying, we are in the process of measuring and evaluating our own systems, and we're probably going to publish a paper around that to demonstrate how accurate the system itself. It goes back to like, hey, who's watching the watchers, right? And so we absolutely want to be watching the watchers and make sure that our error rate is within an acceptable range, and we want to publish that so that you can incorporate that into your calculations when you're starting to use something like Pythia, right? Which you should be, because there's always going to be a margin of error when it comes to any checker or any system that tries to detect hallucinations. And so as long as we know what the bounds of those are, I think it's easier to manage that, which is sort of what we're hoping to accomplish by publishing those numbers. So that helps. Yeah.
Yes, that's definitely where like these weights come in, because like depending on what sort of a what domain you're in, what kind of tasks you're doing, exactly like those the different types of errors can present very differently in terms of the danger. So, for example, if like someone is asking like a question about their medication, or a question for like what over-the-counter medication they can take for a particular problem, if you recommend something and like they maybe have some sort of problem with it, that can be very dangerous, not just for like your company, but also for the person. And so you want to make sure that if you have any sort of like chatbot that's for a particular domain, a highly regulated domain, you want to make sure that it says the correct thing, not just factually, but legally. Yeah, so all of our examples were sort of like the noisy and what was it, the accurate context scenarios. But you can apply these as well to zero context by using an external knowledge base. So we always talk about like having like, you have reference data and external knowledge source, so like a knowledge graph or something. So that's how we would apply to those. So basically, you would run your zero context case, and this other reference that we're comparing to will use that external data to compare it.
Sure.
Yeah.
Right. For example, we have a checker that can go against Wikidata or Wikipedia and sort of validate these kinds of zero context questions that you might want to ask LLMs, right? So that is something that we're planning to make available as well. So yeah, good question. Cool. All right. Hey, we're at time. So hey, thanks a lot for your questions and your participation. So hopefully this was helpful. And like I said, if you have any other questions, drop us a line. And of course, definitely go sign up to our beta program here, listen to the URL here. Looking forward to all your participation and your input. I'm trying to make this product better. Great. Thanks a lot, everyone.
Thank you.